Hello everyone. In this video, I'll be going over how to start in competitive programming. Now, competitive programming is really fun. It's sort of like a math Olympiad, but instead of doing math problems, which might be kind of boring and tedious, you're doing stuff with code, which I find more fun. So to get started, I would recommend checking out this usacode.guide. It's basically something that a lot of really good competitive programmers have made, and it teaches you all of the fundamentals of competitive programming. Now, to actually write the code, you need a compiler and an IDE, or yeah, basically that, or just a code editor. If you want to install one on your own machine, you can look up just G++ compiler, and you can download it for Windows or Linux or whatever, and you should be able to get it somewhere here. This is what I'm using on my machine, which is what you see in my normal videos, but if you don't want to do that, the much easier way to just get started is to use the online GDB compiler. So if you go to www.onlinegdb.com, you'll get dropped into this page where you can actually write code and compile it without having to install anything on your own machine. So now that you have your development environment, let's get started. So how do we make a C++ program? Well, we're going to write a bit of what's called boilerplate, which is like stuff you would have to write in every single C++ program. So we're going to write hashtag include, and then we need these angle brackets, which are like the greater than less than the greater than or less than signs. And then we'll write IO stream, which represents input-output stream. And this is essential for any program you're going to write, because this is how we're going to talk with the computer. This is how we're going to be able to input data and how the computer is going to output data back to us. Alright, now we're going to say int main, and we're going to have parentheses with these curly braces. As you see right here, I'll zoom in so you can see it better. So we have include IO stream, which is basically reading and writing data, and we have here what's called a function, and this is basically what our program's going to be written in. So we're going to write int main, and then let's just say, for instance, std, which stands for the standard library, : cout, 2 less than signs, and then hello world. Now, if you're already pretty well versed in C++, you probably can just like speed forward this part, but we'll write this, and we'll write less than std and l. So what this is basically going to do is it's going to call this cout function from the standard library, and it's going to say, I want you to output hello world to the screen, right? And what I usually do for best practice is I return 0 at the end. And you'll see I have a semicolon at the end of every line. If you don't put a semicolon at the end of every line, your computer's going to yell at you. So let's run this. I have a way of running this, but you can use the online GDB tool, which I'll show you in a second. But anyways, once I run it, you can see it says hello world, and that's exactly what we wanted. Hold on. Okay. So, how would you do this in online GDB? Well, if we just copy this code over to this compiler and just paste it, you can see we just have basically the same thing. You just write the same thing, include IO stream, int main, hello world, and then return 0. And you'll see there's this green run button up here, and if you click that, it'll compile the program and run it, and as you can see, it outputs the same thing, hello world. So if you don't want to install a C++ compiler, you can just go here and write all your solutions here, and it's pretty good. They even have stuff like Vim mode, if you know what that means, which I find pretty nice. So let's get started with some of the more in-depth things. First of all, how would you normally input data, right? So if you look at a problem like this one right here, right? It's problem 1 from the USCO 2015 December contest. And basically, it'll give you input, right? So the problems are all in this input-output format. It wants to give you some lines of input in the form of numbers, letters, you name it, right? And it wants you to output something, usually in the form of an output file or writing directly to the terminal, which is what we did back here, right? So you'll see these two pretty commonly. Either you get an input as a file, as in this case, where the input format is a file paint.in, or it might just tell you that input comes from terminal stdin, which basically means you don't have to do one of the steps I'm about to show you. So how do we read a file? Or just any input for that matter? What we can do is we can use something called stdcin. So let's declare a variable, and a variable is sort of like the storage container that you can put anything inside of, right? You can store stuff inside of variables to access them later. So let's just say int age, right? And then we're going to put a semicolon. And you might be wondering why we don't define it yet, right? If you have done programming before. Well, we're not going to define it because this age is actually undefined. We're going to get it from the terminal. But we're going to say int age, and this is declaring this age variable, right? And then we can say std : cin, which we can see into age. Now notice that these angle brackets are pointing to the right, while these ones are pointing to the left. So these are less than signs, and these are greater than signs. I like to think of it as you're C intoing the age variable, but you're putting this hello world into the terminal, right? So when you want to input something, it goes into the variable, and when you want to output something, it comes out of the variable. I don't know. It's a lot more complicated than I just described, but that's just how I remember it. So we can say stdcin age, and then what you can see here is I can actually output the age variable. So let's say your age is, and then you'll notice I can actually just change stuff at the end of you, which is pretty nice. So I'll say your age is 2 more of these less than signs and another age, right? So it's basically taking this age that we're going to tell the computer, and it's going to say your age is, and finish it off with age. Now again, you can also run this program in the online GDB debugger, but I'm just going to do it on my own terminal. So as you can see, it doesn't output anything immediately. It's going to ask us what your age is. So let's give it, for example, 15. And it says your age is 15. So that's pretty cool. So now we know how to input data, right? And this is how you're going to be getting data in most of these problems, right? Now you'll notice that this problem doesn't actually have an input from terminal stdin, right? It's saying that it's a file called paint.in. So what we actually need to do is we need to read from this file, which I'll show you right now. In order to do this, we need another library. So above you include IOStream, we're also going to include cstd IO, which means it's going to be std. It's like the standard library from the C language, and we're going to be using like the input output, right? So it's just the name of the library we're going to be using. And what we want to do is we want to say free open, and you'll notice we have another parentheses because we're actually calling a function right here. We're going to pass in the name of the file, so it's going to be paint.in. And you'll notice I'm wrapping the string variable, or the string text, I guess, inside of these quotation marks. And that's important. So we're going to say free open paint.in, and then the second argument is going to be whether or not we want to read or write. So in this case, we're going to read from the file, and we're going to say we want to read it into stdin. And you'll realize that stdin doesn't have quotations. So quotations, quotations, no quotations. Alright, so we're gonna read from paint.in into stdin, which is a standard input. Right. Now we can copy this line, and we can actually just write paint.out, writing with stdout. Now that might be a little bit confusing, but you can sort of see a pattern here, right? So we're gonna be reading from paint.in, but we're gonna be writing to this file called paint.out. And you'll see in the problem statement, it says it wants your output to be in this paint.out file. So now that we have that, we can actually read and write data, right? And I'm not going to run this right now because it's kind of hard to actually run this on your own computer, but this will work. And what you can do is when you're just testing out the problem, right? You can do what's called commenting out your code. So you basically, that's kind of bad, but you can just do 2 slashes in front of every line you don't want to be run, right? So these are what's called comments, these 2 slash marks, and they basically say, when you get to this code, don't run it, just skip to the next line. Comments are for humans to read, right? So as humans, we can see these comments, and we can even write stuff like, for instance, get age of person, right? And this will actually not be run. Like, the computer just deletes that when it's trying to run the code. But as a human, you might want to add comments in your code to know what this code does, which is pretty nice. So if you're trying to run something on either your own machine or on online GDB, you can comment out code that you don't want to be run. For instance, we don't want to read the file right now because we don't have the file. So we can comment this out, and then we can uncomment it later. Or not. We can uncomment it later when we want to actually submit the code. Now, one final thing for more advanced competitive programmers that I'd like to point out is you can actually speed up this input-output writing by using something called sync with stdio and cin.tiny. So, how do we do that? Well, you add these 2 lines, and to be honest, I'm not even quite sure how they work. It sort of like unsynchronizes your terminal reading and writing, and it makes your code run a lot faster. But anyways, you just type in std ios sync with stdio, and we're going to say false. So we're going to say we don't want to sync with stdio, and you'll realize that false isn't in quotations, because false is what's called a boolean, and it's not a string. Then we want to say std cin.ty null, and null is in all caps here. So if you just add these 2 lines, which I'm not going to explain, it basically just speeds up the execution of your code. So you'll see that a lot of these problems, it doesn't say anything right here, but so you see it says 4 milliseconds, right? These problems will have a time limit, like how fast your code can run for. A lot of them, I think it's like 2 seconds. So if your code runs for more than 2 seconds, it's going to automatically say that your code is wrong. And this is actually a big problem in a lot of these problems because you need to optimize your code, and this is just a future reference, but you need to optimize your code so it runs under 2 seconds. And sometimes it'll give you huge data sets with like 1 billion different numbers, and your code has to still process all of that data in 2 seconds. This just makes it so that it reads that data faster, so you don't have to actually worry about reading data quickly. So, just a small bit of information for you. So yeah, that's about it for input-output and like just reading from a file, outputting to the terminal, whatever you want to do. So I'll give you an example of a problem, and this is basically the problem I've been showing, which is problem 567 from Yusaku. And as you can see, I've already written the solution, and you'll see I have these 2 lines, which are speeding up the input-output. I have the free open to read the files, and that, like, all of this is just the exact same. And what we'll see is I have this cin right here. So in A, B, C, D, I'm seeing into these integers, which is exactly what I taught you earlier. And I have some more complicated code down here, but what you'll realize is I'm writing the output with stdcout and stdendl. So yeah, all of this stuff is applicable, and you'll use this when you actually do a lot of competitive programming. And again, these are just the basics. I'm not going to go into if statements or loops or like any advanced stuff in this video, but just to give you a head start, this is all the stuff you're going to be needing, all the basics you'll need. And to show you that how this code runs, I'm actually going to submit this. So this is code. This is file 567.cpp, and if I go here, you can see it asks for the language. And we're using C++ right now, so I'm going to select C++11, and I'm just going to browse for the file. 567. Here we go. So as you can see, if you're going on UserCode, you can submit files by selecting C++11, finding your file, and then just click Submit Solution. And it'll start grading you, which might take a little bit. But there we go. And you'll see that this solution works when all the boxes are green. So yeah, these are just some basics that you'll use later on in competitive programming. I probably rambled a bit in this video, but do give a like if you enjoyed the video. And yeah, that's about it. Thanks for watching, and I'll see you in the next one.